Day 11. It's like I'm fucking on an island with a coconut and a soccer ball, writing my fucking journal. Day 9 lecture. Last week, we went over the general addition rule for probability, just as a reminder, throwing it up for you. We had the probability of E or F equal the probability of E plus the probability of F minus the probability of E and F. Now, some books use a slightly different notation. I was showing this in our support course. Or is also, they can also do E union F. That's another way of doing or. And another way of doing and is the intersection. But I don't like it. I don't think it's descriptive to most people. It's only descriptive to people that speak terrible math jargon. E or F implies that it can be in either group E or it can be in group F. It's pretty fucking clear. Or means or. That was last week. Today we're doing 5.3 and 5.4. 5.3 and 5.4 are dealing with more than one event. At the same time. Not like looking for an overlap, like this has like E and F are two different things, but this was like rolling doubles or rolling an 8. Which we did last week. Remember doing the Monopoly shit? We did the Monopoly shit and like that was that, but like it was the same roll. Here, this is like talking about how two different dice affect each other at the same time. So 5.3 is on when the events are independent. This happens if we have two events going on. And they don't affect the outcome of the other. If that's the case, we say the events are independent. Examples of this are like rolling more than one die. If we're drawing cards from a deck, drawing cards from a deck, but replacing them after each single card is drawn. So long as the deck has all 52 cards each time you draw it, they don't affect each other. If you keep a card out, now there's one less card, there's only 51 cards and they are affecting each other. In 5.4, we will talk about dependent events where they do affect each other. For independent events, E and F, the probability of E and F equals the probability of E times the probability of F. This is worth making a little note about for yourself. You have the and, it's multiplication. The or is addition. Addition and subtraction. But like one is multiplying and one is dividing, and it's always consistently the same. Or has addition. You're doing two different things, putting them together.
Or you said or is just addition?
Yeah, also there's subtraction there, but
Or okay, or and subtraction. Gotcha,
the multiplication goes with and, the or goes with the addition and subtraction.
gotcha.
Okay, you guys ready for an example? Has anyone not played Yahtzee? Okay, so this is how Yahtzee is played. Yahtzee is a perfect example for this. Because we got a lot of independent events going on here. Yahtzee is a game where you roll 5 dice. The actual Yahtzee is getting 5 of a kind. So we could have ones, and that's one form of Yahtzee. That's what I mean by 5 of a kind. The face-up point is the one that happens. And in the game, you get 3 throws, but we're not gonna look at that. Three tosses, and you can re-roll whichever dice you want. What we're gonna do, that's the game of Yahtzee. We're gonna look at getting a Yahtzee in 1 toss. Probability of getting a Yahtzee in 1 toss. So this is like the probability of getting all 1s or 2s or 3s or 4s or 5s or 6s. That's what we're looking at. And the word all should apply to each of these. But I didn't write it because it gets tedious writing all. Even though it's only 3 letters, I think it's implied. So from here on, I'm not going to write the word all anymore. What did we just say about or? What did or mean in terms of signs here?
Plus.
It's plus. So I can rewrite this as the probability of all 1s. I'll write it for the first one here. Plus the probability of all 2s. Plus the probability of all 3s. Plus the probability of all 4s. Plus the probability of all 5s. Plus the probability of all 6s. Now, each of these are identical, so we only need to calculate one. Identical in probability. So we'll calculate one and then we'll use that same one for all 6. So Beta, what's your favorite number out of these 6? If you throw 7, say it's 7, I'm throwing your ass out.
4.
4. Let's look at the probability of getting all 4s. That's the same as the probability of the first equaling a 4 and second equaling a 4 and third equaling a 4 and fourth equaling a 4 and fifth equaling 4. Oh, that was a tight squeeze with my big ass marker. Only I condensed it down a little bit more on the left. What did we say and meant? Means multiply. So this is the probability that the first equals 4 times the probability that the second equals 4 times the probability that the third equals 4 times the probability that the fourth equals 4. Isn't this fun writing this down? Times the probability that the fifth equals 4. What is the probability of getting a 4 on a single die? It's 1 out of 6, right? There's only one outcome that's a 4 out of 6 total outcomes. And that's the same for each of these. A shorthand way of writing this is 1 over 6 to the 5th power. But if you want to know what that is in terms of probability, it's 1 over 7,776, which is 0.000128 You have less than a 0.01% chance of rolling a Yahtzee in a single class. Of fours. Of fours. That was just doing this green equation though. So we need to come back up here and do the total Yahtzee. So any Yahtzee was this equation. And each of them have the same probability. It's 1 over 6 to the 5th power. This is 6 over 6 to the 5th power, which is really just 1 over 6 to the 4th power. The odds don't get a lot better. Now we're looking at 0.0007716. Now we got a 0.07% chance. 0.7 or rounded up to 0.8. Yeah, I'm off the screen, aren't I? That is doing the probability for independent events. There's all this multiplication. And we added the general addition rule. This is like a combo. Now, there is a smarter way of doing this. It's not a lot faster, but it can help. This might help you on some problems. If I want a Yahtzee and I don't care what number, does the outcome of the first die really matter? Die is singular for dice. a shorter way of doing all that probability, because this was two big equations that we just did. If the first die I roll, like it stops rolling first and it's a 4, I don't want any other number but 4 on the other dice. So it's really, and it doesn't matter what the first die is. If it lands on a 6, I don't want anything but a 6 on the other dice. So the way the first die lands doesn't matter. We can look at this same thing as doing probability of a Yahtzee is the probability that the second matches first and third matches first. And you go through this and you do, and fourth equals first and fifth equals first. And the and turns into multiplication. Probably that second equals first times probability that third equals first. And I'm talking about the way the dice land, like the third die to stop rolling. The probability the fourth die matches the first die times the probability that the fifth die matches the first die. Each of these is 1/6. And I get to the 1/6 to the 4th power much quicker. We had less work in this process. First off, I didn't have two equations. Two big ass equations. These were ugly. Writing both of these, that was ugly. That took up a lot of time. This same idea works with dependent events, which I'm going to use this next example as a segue to dependent events. But if you have played Texas Hold'em, what is the probability of pocket aces? So in Texas Hold'em, you're playing poker, there's 7 cards, 2 of them are your cards. You get 2 face down cards. Face down means no one else can see them. These are your pocket cards. Then there are 5 cards that are played on the table that everyone gets to use to make their poker hand. I'm not going to go into a long spiel about how to play poker. There's a lot of nuance in playing Texas Hold'em. It's a lot of fun. I have a lot of fun with it. But your 2 pocket cards are yours and no one else's to see. And you don't want to give away a good face when you have a good hand. Having a pair to start off with in your, another way of calling it a pocket card, they also call them your hole cards. So we're looking at the probability of having an ace in here. 2 aces. Now, this is very much a dependent event situation. Because after the first card is drawn, there's less aces to get. So this is gonna segue to 5.4. But this idea here of the first one doesn't really matter actually meshes up well with this. As you'll see in a second. This is the same thing as the probability that your first card is an ace and your second card is an ace. And this turns into multiplication. But you have to pay attention to what's going on with the probability. In a deck of 52 cards, there are 4 aces. And when you haven't seen any other card, you have a 4 in 52 chance of getting an ace on the first card. And the probability of your second card, assuming you don't see any other cards, and you don't, the whole cards are all dealt face down, you don't see anyone else's cards. After the first card, there is only 3 aces left in the deck. And there's only 51 cards left in the deck. You've withdrawn 1. And I got that by doing 4 minus 1 over 52 minus 1. When you simplify this, you get 1 over 221. Or 0.45% chance of pocket aces where both cards face down. Another name for them, I like the name pocket rockets because the ace looks like the tip of a rocket head. It's a good name for them. That is really generally like 95% of the time the best hand to get. Pocket aces don't get beaten often if you play them right. As long as you don't have like Texas Hold'em, if you don't have someone that will just play any 2 fucking random cards all the way to the river, then you will take their money 95% of the time, but every once in a while they'll fucking get lucky as fuck and they'll take you for everything you got. They're gonna lose a lot of money in the long run. They lose more than they fucking win. But when they beat your fucking Rockets, you're fucking pissed. You know, like a 2-7 offsuit, fucking taking out your Rockets. You're like, you motherfucker, I raised heavy a lot. You should have folded if you had any fucking half of a fucking brain.
That's straight flush.
Yeah, though you can't even draw straight flush with 2-7 offsuit.
I beat pocket aces.
What?
I beat pocket aces.
It happens. It's different, like if you get pocket, like a different pocket pair and you just like hit up on trips or something. So how does this mesh up with the idea of what I was saying earlier? What if you just want any pocket pair? Any pocket pair is good. There are 13 ranks. So there's 13 ways to get, or 13 different pocket, or well, 13 different ranks of pocket pairs. Then we would do that 1/221 and we do it 13 times. And we would get 13/221, which is 1/17. 0.0588, which is approximately a 6% chance. So when you have all of the, like any pocket pair, getting a pocket pair, it doesn't happen very often, but it's a hell of a lot more than pocket aces. Rather than doing this long calculation of doing this and doing 13 of them though, we can use that mentality of, does my first pocket card match or matter? My first whole card matter for any pocket pair. No, it doesn't. Only does the probability that the second equals the first. That's all that matters. The probability that the second card equals the first, we actually just wrote it down up here. Is 3/51. And if you simplify that, you get the 1/17. Pocket pair is an example of dependent events. Probability for the second card was different. Different than the first card. This is the subject for 5.4. Five point four is on dependent events. But since we're about 40% of the way through our 2-hour period, here's a good chance to take a 5-minute break. Let's take a break before we get this section started. Let me hit pause. Mr. Jones. I will do just as you wish. We will continue this lecture. So 5.4 dependent events. This is where or when the outcome of one event affects the outcome of another event. Fucking Taco Tuesday. Food just popped in my head. I want to see if that taco truck does like chicken empanadas. Al Pastor was pretty good, Angel.
You eat it with the grilled onion?
Yeah. The grilled, I like that grilled onion is awesome. Compare these two things. For rolling a die. Rolling a single die. What is the probability of getting a 3?
That's 6.
1 out of 6. What is the probability of getting a 3 if we know it's odd?
It'd be 1 out of 3, because there's 3 odd numbers in the die.
There are only 3 odd numbers on the die. Yes, this is gonna be 1 out of 3. This sample set only has 1, 3, 5. The way they write this, rather than saying if we know it's, they write this like this. Probability 3, they do this big vertical bar, and then they would say odd. And that bar is a handy way of saying given. So the probability of a 3 given that it's odd. This sounds like some shit you'd see on Price is Right or fucking shit like that. In general, if they write probability F like that, this is read as F given E.
When you say that, we know it's an odd, like, we know that a odd number is going to roll.
Yes,
Only, like, there.
like some, like the rolls happen, you can't see it, but your buddy's looking at it, it's blocked, and he goes, it's an odd outcome. That kind of thing. Like this is some shit you'd only see like in like game shows and shit like that. That scenario, but this scenario of stuff happens all the time. We just had this here. The probability that the second card is an ace, given that the first card is an ace. We just did this for Pocket Rockets. The second card can be an ace without the first card being an ace. You wouldn't get a pair. And the probability would be different. So there's a couple ways to write the equation that how to solve this. One is doing the probability of E and F divided by the probability of E. Or you can do, we did this with probabilities in general, the number of outcomes in E and F divided by the number of outcomes in E. This format works well if you have probabilities. This works better when you have a table of results. And I am going to retire this blue pen right now. Put it in my fucking pocket so I quit trying to write with it. Because it's going dead, right? If I leave it in reach, I'm going to fucking grab for it again. Get it out of my line of sight. grab a fresh blue pen. That's a new job, Johnny.
It's good, it's good, I kind of started understanding it, it's, how they format the housing, like the writing of the housing, because I'm working the reroute desk. Like we would go A5, and now it's, or it could be 4A. And it's like you had to write this number, or one in the middle, and then like 3 on the other side, it's pretty crazy. Makes me want to do that.
So fun fact, I've been playing Scrabble on the phone with my wife. Like on the app. And I had the letters for fart. That motherfucker wouldn't let me play it. The game would not allow the word fart. He said it was a legal word. And I'm like, I know it's in the goddamn dictionary and it's not, it's not a cuss word. Is it falling under slang?
It's probably obscene. You can't use obscene.
You can't? I'm gonna try to use obscene now from now.
They said build your letters and call it flatulence.
Oh, yeah.
You can't spell flatulence,
I know.
And maybe it is slang.
but it's used more than fucking the original. No one says flatulence. Anybody that says flatulence, you're immediately like, that's a pretentious prick, right? They fucking got their pinky up, sipping their fucking tea,
I can't even spell flatulence.
So, yeah.
right? I normally only play my wife. I randomly played someone else. I swear to God, they cheated at the end. I had a lead on them, not by much, like 10 points. We only had a couple tiles left. She had one fucking tile left. She managed to find a fucking one spot that she put her eye in it, and it gave her like words in both direct, like a fucking a multitude of fucking like it filled up like a grid. And like one of the words she made was CADIS. I don't know what the fuck what that is, and I have a pretty good vocabulary. So I'm calling bullshit. That stupid fucking game though will allow you to like hit a button and you watch a fucking ad and it'll show you what was your best move in the last turn. And so if you fucking play it at the end, your best move is probably was playing the ice, you probably hit it, and it's like, oh, I got an idea for the next round. It's fucking a chicken shit way to win. She ended up like getting just a few more points. I'm like, nope, not playing you again. You're a fucking cheat. All right. So that should have given you time to write that shit down. I want to manipulate that probability equation right there. If I multiply both sides by probability of E, I will get probability of E and F by itself. And on the other side, I have probability of E times probability of F given E. So this is another way of looking at the equation. In fact, I'm gonna rewrite the old one, the one for, so this is dependent events. Look at this nice crisp blue pen. Smaller fine tip point. For independent events, we had this. That was for independent events. So this actually gives us a great way to test for independence. If the probability of F given E is the same thing as probability of F. Then F and E are independent. This is like saying E happened. But the probability of F hasn't changed. Which means E didn't affect F. I haven't had any drops today, and I was sure I was going to. Today was calculus class first test. Some people didn't even show up. And I know on at least one exam, I saw on the front, where they dropped it off, was sorry, Mr. Jones. I didn't study as hard as, like, I'm embarrassed. I didn't study as hard as I should. I've overbooked this semester. I'm gonna take calculus later. But that person hasn't dropped yet either, and they actually said, I'm gonna take it another semester. What?
Calculus is tough.
Calculus is a breaking point like algebra is in the math sequence. Either when you, like, some people are great with math, they love math, and then they go like, I hate algebra, which means they got all the way up until they could use like variables.
Well, at least algebra has rules.
Algebra has, calculus has rules too.
Yeah.
They're just less applicable to daily life.
Yeah.
I was actually, I think I was talking to Angel about this, the other Angel, this weekend about it. She's like, she didn't know what the difference was.
You can easily see the effect that the rules have on your variables, but on calculus, it's a lot more.
You can see the effect if you know what you're doing. On calculus, what you're looking at is how things change in relation to other things. How does something change over time? How does something change over a given distance? Stuff like that. It's how rates of change. It's one of the main focuses of calculus. And does a lot more crazy stuff with math. All right, let's look at, we'll do a couple examples in this section. I'm gonna start 5.5 after this, but there's no way in hell we're gonna finish 5.5. You guys are a section behind the morning class. We did 5.4 and 5.5 today with that. We took too long last week. That was probably because, don't tell the fucking morning class, but I enjoy talking to you guys more. Shh. They probably won't watch this. They don't interact with me. Very few of them like ever talk. It's kind of hard to teach fucking 40 students that like, just like stone faced and don't fucking respond. Don't even laugh. Like, even when you fart, there's nothing, I get nothing out of them. So here's our first example. In 2005, 19.1% of all murder victims were 20 to 24 years old. I'm gonna say this 20 to 24 years old a few more times. I'm tired of writing years old already, so I'm gonna just say 20 to 24 later on. Also of note was 16.6% of all murder victims (20 to 24-year-old males). What is the probability that a randomly selected murder victim, this is fucking sounds dark in my head every time I say it. That is 20 to 24 years old ends up being a male. Okay, so let's tear these sentences apart one by one. Sentence number one. Nineteen point 1% of all murder victims were 20 to 24 years old. So the probability of a murder victim being 20 to 24 was 19.1%. As a decimal, that is 0.191. I'm going to use MV for murder victim. Otherwise, this makes a really long parentheses. Sentence number two. The probability that someone was a murder victim that was 20 to 24 years old and a male was 0.166, the 16.6%. Sentence number three, what is the probability that a randomly selected murder victim that is 20 to 24 years old, and then we have ends up being a male? It sounds like in sentence three, the given part is that they are 20 to 24 years old. And the part we're checking for is, are they male? This, in our new notation, would be the probability that the murder victim is male, given that the murder victim is 20 to 24 years old. So we had an equation for this topic. It was probability of F given E equals probability of E and F over probability of E. It looks like my F here is male murder victim, and my E is the age range. So if I want to write this equation in terms of this information up here, what I'm doing is probability that the murder victim is male, given that they were 20 to 24 years old, equals probability the murder victim was 20 to 24 years old and male, divided by the probability that the murder victim was 20 to 24 years old. That's just E. We use that, we have the numbers for these. The top one is 0.166. The bottom one is 0.191. And I'm getting 0.869. Or approximately 86.9%. This kind of makes sense to me. If we're talking about people that get killed, I think more guys kill guys than girls kill girls if we're talking about same-sex murder. And if we're looking at like different sex murder, like guy killing girl, and guys are abusive to women. People, piece of shit guys are abusive to women. But usually that doesn't go to the point of killing. Generally, if there's killing in the relationship, it's the woman that got tired of his shit. And the only way to fucking deal with it is you can't take him on while he's awake. So you stab that motherfucker while he's sleeping. So I'm thinking there's more guys that kill, or more girls that kill guys than guys that kill girls. All around, the guys are just getting killed more than girls are getting killed. So that's why 80%, 87% of people that age that are murdered are male. That is 2005. I wonder if it's changed much. I don't know. Kids nowadays, they're growing up different than I grew up. They really are. Like this is more along the lines of how I grew up. But nowadays, like there's fucking 13 billion different fucking gender identities and like all sorts of shit. And like it's totally alien to me. I get the concept. Seems excessive to me, but it is what it is. They're very in touch with their inner selves, and maybe they're less likely to kill each other over it. I don't know. They tend to be more tolerant of the differences in other people. That's what the younger generation has going for them right now. What's not going for them is they're dumb as shit. Fucking stupid.
Probably because we're focused on
They don't know how to use fucking technology. How do you fucking grow up with a goddamn computer and can't use it? It's only good for fucking TikTok and Instagram to them. I don't know. I don't get it. I think my theory is us old people like technology more because we didn't have it. If you're old enough, well, we still have public libraries. But if you're old enough to like the only way to get a free book was to go to the public library, you know what I'm fucking talking about. You go check it out, you gotta return it a couple weeks later. Nowadays, you get them on Kindle left or right. You can download PDF after fucking PDF. Anything you want to know. Go to the library for an encyclopedia, look that shit up, find it in the library. Now it's just Google. All right. Next question. A survey was conducted about faith. There were 3 answers allowed. You could say you believed in God, whether it's the Christian God or another God, just a singular God, or a universal spirit, maybe like Mother Nature. That's not really a God, but we give it like a spirit. It's like a pagan belief. Or you could be just like a total scoundrel like me and be an atheist. They asked this over 4 regions in the US. They asked in the East, the West, the South, and guess what the 4th group is? You really want to say North, right? No, these dumb shits went with Midwest. I get it. There's not a lot of people in northern, like central northern United States. But if anyone's got a different group than like everywhere else, the Midwest is basically, I don't know why it's called Midwest. It should just be mid-US. The Midwest is the fucking center of the country. It's your good old Bible Belt. This was the answers they got. So we'll have a column for region. And here we had East, Midwest, South, and West. And for columns, we had God, Spirit, Atheist. I think we'll do a final row on bottom for a total, and a final column on the right is a total. I hate when they do a bunch of fucking numbers stacked without having like little markers. So I'm doing a little marker halfway down, so it's kind of easier to spot where everything's going. So these are the values. Think about this earlier when I was doing this with the other class. I never really considered Mother Nature, Gaia, or whatever, as like an entity. But if I were to worship something, that sounds like a good fucking choice. I can see it, I can stand on it. It provides me food and water, and it keeps air trapped in its region so I can breathe. It's a pretty good fucking overseer, right? Takes good care of me. That seems like something worthy of worship. I'm not going to do it, but I can respect the earth and try to treat it right by doing things like recycle and stuff like that. But I'm not gonna try to keep the air clean. Because that would require me to fart less, and you can go fuck yourself on that. All right, so the totals are, I got a 787 here. This is 167. This is 63. For a grand total of 1,017. The top row adds the 255 and the rest add to 254. we're gonna look at two questions. What is the probability of someone who A, lives in the West, is an atheist, and B, someone who is an atheist lives in the West? All right. Anyone need that up longer? We're gonna use this, but I need another page to do the work. So I'm gonna keep the table apparent, but I'm gonna hide the questions. And I'll just rewrite them as I'm doing them. So the first one is someone who lives in the West is an atheist. This is a dead pin too. Pocket for you. You'll notice real quick, those sentences have the exact same words, but in a different fucking order. Is an atheist and lives in the West. They just show up in a different order. And they drastically change the answer to this scenario. So the first one is the given piece of information. This is the restriction we're placing on it. We want to only look at people that live in the West. The probability that they're atheists is what we're looking for. So we are looking at for the probability an atheist, given that they live in the West. So this is like my F and E. So this equation should be, or it's equal to probability of both atheist and West over the probability of West. Now, I don't have probabilities here. There was another form of this equation. The other form of this equation was using the numbers. So number of atheists and West over number that live in the West. This is an alternate form and the result is the same. In fact, I'll show you the other one. The result is the same though. How many people from this table are atheists that live in the West? 26. Not Midwest, just West. 26 people live in the West that are atheists. It's this column right here,
Oh,
that row. How many people live in the West? 254. So one handy way of doing this is just like, if you're focusing on a given row, like in this case, the given row is West, just cover up everything else. The rest is just clutter for what I'm trying to look at right now. Other than the titles of the rows, I kind of need them right now. But like, other than the titles of the rows, those other sets of numbers don't mean anything because I'm just looking at this row right now. So 26 out of 254, how much is that? 0.102. Which is about 10.2%. We can do the probability one, but I'm going to show you why it sucks. Doing probability of atheists and West over just probability of West. The probability of being an atheist in a West is 26 out of 1,017. And the probability of being in the West is 254 out of 1,017. Now, if you plug this into a calculator and you do it correctly in all one stream and you put it in right, you'll get the same answer. But this is fucking not easy to do. There's fractions in fractions. And even if I just do the top separately and write down a decimal and do the bottom separately and write decimal, I'm probably going to round because there's probably an unending decimal numbers. So like rounding generates errors. And so my final answer, the error might be more than I expected if I don't like give enough decimals. Another way of dealing with this is manipulating the fractions. You can always multiply by the fraction upside down. And if you do, it cancels the stuff out and it only equals 1. But if I multiply the stuff out on the bottom by it, I got to multiply the stuff on the top by the same amount. If I do the 1,000, not equals, but times there. The 1,017s cancel and I get 26 over 254. So doing some like manipulation of the fractions, this is a lot of math that Michaela is immediately fucking tapping out on. She's like, fuck all this. But she can fucking read 26 to 254 from that chart and go, I could throw this in a calculator. It's not the end of the world. Hopefully. Hopefully she's not going, that's too fucking much too. If she does, it's going to be a rough semester. So I don't recommend this. I don't recommend probabilities if you have numbers. Or like F and E kind of thing. If you have the numbers. Or counts. What about question B? Question B was someone who is an atheist, lives in the West. Well, now I need this atheist column. Oh shit, over here just fucking hidden buttons. Thankfully, it was just brightness. And this was the west row. Or yeah, west row. So now the given part. This is my given piece. And this is what we're checking on. So here we have probability of west given atheist. The top ends up being the same. It's probability of atheist and west. And we already said we didn't want to use probability, so I'm gonna just change that to an N right now. The bottom is the number of people that are atheist. We already said the top number was 26. We can see from the table there were 63 atheists. Which is 0.413 to 3 decimal places, or 41.3%. All right, so what if I put these numbers in wrong? What if I do 63 over 26? Even if I write them down correctly, if I put them in the calculator wrong, I could write this down, but you would be surprised how many students will treat this as 63 divided by 26 when they put it in the calculator. It's always the top divided by the bottom. If you do 63 divided by 26 instead, you are going to get, this is approximately 2.423. What is that mean? What does that mean?
42.3%.
It means, right, it means 242.3% of atheists live in the West. If I put it into words, that's what it means. Does that make any sense whatsoever? No. 100% is the cap, no matter what anyone says. The people that say, I'm giving it 110%, what they're really saying is, I give everything else maybe 75 to 80%. And I'm willing to give you above 90. There's no way in hell you're giving anything 100%. Everyone needs a goddamn break. The only thing on this planet that you're willing to give 100% of your fucking time to is breathing. Guarantee it. If you find something else you want to do as much as you possibly want to breathe, then you can give 100% to it. But I guarantee you there's nothing on this fucking planet that does. Not food, not drinking water, not sleeping. Well, if you don't have enough sleep for long enough, you might want it really, really bad. But stop breathing while you're doing it and you'll quickly find out, nope, I still want to breathe more than I want to sleep. All right, so that's what happens if you fuck up. If you put it in the calculator wrong or you write it upside down, if you get a probability that before you convert to a percentage, it's above 1, you done fucked up. You flipped it upside down more than likely. More than likely it's upside down. All right, let's take a quick peek at 5.5. We're not gonna get anywhere near done, but the more we get done today, better off we get. 5.5 is on counting techniques. A typical California license plate. Looks like this. It's got a number, it's got 3 letters, and then it's got 3 more numbers. How many different combinations are possible? Well, what about the first number? How many different options do I have for the first number?
9 options, right?
For the first number, I have 10 different options.
10.
1 through 9 and 0.
Okay.
A lot of people forget 0,
Right.
but it does count. Even though it represents nothing when you count it, it is a number. How many different letters can it be?
6.
Hopefully everyone got that right. Same with the second letter and the third letter. And any of the numbers, later numbers could be that as well. You can have repeats on a license plate. If you multiply this out, this is 175,760,000. So like if I wanted the license plate, the probability of my license plate being number 1, DRJ 007. DRJ is my initials. If I wanted DRJ is number 1, 007. There's only one license plate like that out of 175 million fucking combinations. I'm not even gonna bother writing this as a decimal. It's absurdly fucking low. I think I have a better chance of randomly winning the lotto, to be honest. I think there are less combinations of winning lotto tickets. In fact, we'll look at doing the lotto on next week, because we're not gonna get to it today.
Well,
Not next week, Thursday.
there's a movie about that. There's some guy who would buy like a lotto ticket and he'll win like every time. He'll get big.
The only way to make sure you win every time is to buy every single combination of tickets.
Yeah, he would.
It's physically impossible. He would buy a lot, and if you bought a lot, you might get it to like 10%, where you win more often than a normal person would, but you're spending a lot of fucking money. The only way, when you see how many tickets there are, you can't fucking scan the fucking lottery ticket thing to print out a lottery ticket fast enough to get as many lottery tickets as there is before the next lottery drawing. Even if you started fucking 1 minute after the last lottery drawing, you don't have enough time. You would need an entire team of people
Yeah, him and his wife, they started assembling a lot of people. So like those lottery scanners, they'll have like 4 trusted places. They'll go and split the ticket. Like,
You would need a lot more than 4 bucket people.
yeah, but it was like a lot, like they would not stop going for like hours, like days.
Right, yeah, yeah, you can increase your odds by the more you buy. But the only way of making sure you get it all is buying every single ticket. And that's really only worthwhile if the jackpot is worth more than buying every single ticket. And that actually doesn't happen all that often. We'll take a look at that later. On Thursday, we'll hit this, the lottery thing. That doesn't happen that often, but well, like, what about like no repeats? What about if we can't have repeats? Well, my first number can still be a 10 and 10 different choices. The second is 26. What about the second letter? How many options do I have? 25. It decreases, right? That's going to decrease too. When I get to the numbers, the 10 will no longer be a 10, it'll be 9, then 8, and then 7. This leads to 28,624,000 combinations. This is called the multiplication rule of counting. You just multiply the options. So you know, like you go to Chili's, they have that dinner for 2, or Applebee's dinner for 2. Pick a restaurant. There's a good chance they have a dinner for 2 option, and you can pick one appetizer out of like, let's say, P different options. Each place is different on how many they offer. And then you can pick 2 entrees out of, let's use, well, entree starts with E, we'll use E here. E options here. And you pick 1 dessert to share, because the people that came up with this dinner for 2 really don't know how dessert works. We'll use D for that. The total variety of meal combinations are and I'm gonna just say pick 1 entree for now. You only care about your own entree. This having 2 entrees changes the shit up. I don't want to do that. It's P times E times D. That's what we were doing up here. We were multiplying them all. And I think the other thing I have time to show you for, I don't really want to show you right now, because I'm just gonna have to show you again, but maybe I will. Maybe if I do it twice, it'll stick better. Right? More often you hear something, the more likely it is to stick. Some of you may already know what this is. They're called factorials. Angel's like, slow down. Fucking writing as quick as I can.
I would like totally my hands to bring up.
Crap, that fucker. Factorials. They have an exclamation point with them. On a calculator, and I'll show you how to find them later on, you can see them with an X exclamation. Or if you have a PRB button on your calculator, this usually gives 3 options: N factorial, NCR, and NPR. The top one's a factorial. Rather than put it into words, I'm just gonna show you what they are. And you're gonna see it, you'll be like, I fucking get it. Four factorial equals 4 times 3 times 2 times 1. Can anyone tell me the pattern here?
Counting down.
Well, that number just keeps dropping, right? And we keep multiplying. And we don't go to 0. Because 0 would make it 0. Multiplying by 0 kills it. Multiplying by the 1 really doesn't fucking help either, but it completes the pattern. 6 factorial is like doing 6 times 5 times 4 times 3 times 2 times 1. Or I could write this as 6 times 5 times 4 factorial.
6 has 2 5s.
What?
It doesn't.
Thank you. That was me just fucking writing random shit. That's how factorials work. You would actually multiply them out and get a number. Calculators have these. What we do with permutations and combinations, we'll do on Thursday, use these. It's in the equations. But one last final handy thing to note is if we had something like 6 factorial over 4 factorial, I could write them all out and cancel. The 4, 3, 2, and 1 cancel on top and bottom. And I'm just left with 6 times 5. So you may not need a calculator for everything that's factorial. Another way of looking at this without writing everything out is doing 6 times 5 times 4 factorial, and then just leaving the 4 factorial on the bottom. Counting down on the factorial until you get to the one that's on the other side. Because these two cancel out, and we're still left with 6 times 5, which is 30. That's something we will take advantage of on Thursday. That's how factorials work. They're relatively simple. They get large really fucking fast. Have a good evening. GTFO. You too.